In this example, we will anti-differentiate the given rational function. Now the first observation that we make is it is a degree 3 divided by what will be a degree 5, so it is a proper rational function. So our first step in terms of proceeding is to come up with the form of the partial fraction decomposition. Now looking at the denominator, you have a linear term and a irreducible quadratic which is repeated. So the form of our partial fraction decomposition will contain 3 terms, but as we'll see, 5 unknown constants. So let's go ahead and write out the form of the partial fraction decomposition. So corresponding to the linear term, we'll have an a over x minus 1. For the first occurrence of the irreducible quadratic, we'll have a bx plus c over x squared plus 4, but it's repeated, so we'll also have a dx plus e all over the quantity x squared plus 4 squared. So just like any other partial fraction decomposition we've worked through, our first step is to take this denominator on the left and multiply each term by it. So the left-hand side will be x cubed plus 10x squared plus 3x plus 36. And on the left-hand side, in the first term, the x minus 1s will cancel. In the second term, one of the x squareds plus 4 will cancel. So we'll have an x minus 1 times x squared plus 4. And in the last term, both of the x squared plus 4s will cancel. And there's an x minus 1 with it. And at this point we note that corresponding to the linear term, there should be an intelligent choice that we can plug in for x to immediately solve for a. And that intelligent choice will be 1. X equals 1 would make the second and the third term vanish. So working this out here to the side, if x is equal to 1, what we will have on the left-hand side is 50, and on the right-hand side this will be equal to a times 5 squared. So a times 25, which tells us that a is equal to 2. At this point, there are no more intelligent choices that immediately allow us to solve for a given constant, so really the next plan of attack would be to expand everything out so that we can set up a system of equations. And I'm just going to go ahead and skip a few algebra steps, and if you expand this out, you will have a plus b times x to the 4th plus c minus b x cubed plus 8a plus 4b minus c plus d times x squared plus the linear term is minus 4b plus 4c minus d plus e, and the constant term is 16a minus 4c minus e. And on the left-hand side, this is going to be 0x to the 4th plus x cubed 10x squared plus 3x plus 36. And the only way these two quartic equations are going to be equal to each other is if each of their corresponding coefficients are equal. So to start off with, if you look at the coefficients of x to the 4th, that gives us our first equation. So the x to the 4th equation would correspond to a plus b being equal to 0. And let's just go ahead and note at this point, since we know a is equal to 2 from our previous work, we have b is equal to minus a, which is minus 2. Now if we compare the coefficients of the x cubed terms, we have 1 is equal to c minus b, which if we work with this, that tells us c is equal to 1 plus b, which is 1 minus 2, which is minus 1. So really determining that value of a in the beginning was key in terms of simplifying our work in these later steps. Comparing the coefficients of x squared, we have that on the left-hand side it's 10, and on the right-hand side it's 8a plus 4b minus c plus d. So 8a plus 4b minus c plus d is equal to 10. So let's go ahead and plug all of our values in. So we have 8 times a, which is 2, plus 4 times b, which is minus 2, minus c, plus d equals 10. And what those numbers add up to on the left is a 9 plus d equals 10. So d ends up being 1. Then looking at the coefficients of the x term, we have from the right minus 4b plus 4c minus d plus e equals 3. And then looking at the constant term, we have 16a minus 4c minus e is equal to 36. And at this point, let me know we can use either of these equations to solve for e, but the bottom one only involves 3 constants, the a, the c, and the e, opposed to the top one. So I'll just go ahead and work with the simpler equation. So plugging in our values, 16 times a, which was 2, minus 4 times c, which is minus 1, minus e is equal to 36. Well, 16 times 2 plus 4 is 36. So 36 minus e equals 36 is equivalent to saying that e is equal to 0. So at this point, we've started off with our proper rational function, and the form of the partial fraction decomposition had these 3 terms in it. And we've gone through the standard procedure, set up a system of equations, and solved for those unknown constants. We are now ready to anti-differentiate. So at the top here, we have the partial fraction decomposition from the previous slide. So let's just go ahead and immediately break this up into 4 different integrals. So we are going to have the antiderivative of 2 over x minus 1. Then that next term can be broken up into 2 pieces. Minus the integral of 2x over x squared plus 4, minus the integral of 1 over x squared plus 4, and then the last term would be plus the antiderivative of x over the quantity x squared plus 4 squared. And let's just go ahead and anti-differentiate each of these term by term. So the first antiderivative will be 2 natural log absolute value x minus 1. The second antiderivative, this is something that you could just write down for me without any work, or if you're not seeing what it should be, you can think of a u substitution. You have x squared plus 4 in the denominator, and its derivative appearing in the function as well. So you would let u be x squared plus 4, and the 2x dx would be exactly your du. So 1 over u, natural log absolute value u, and we just plug in that x squared plus 4. For this next term here, let me remind you of a common formula. If you have the antiderivative of 1 over x squared plus a squared, this will be 1 over a arctan x over a plus c. Since our integrand has x squared plus 4, the a value in this case is 2. So we get back 1/2 arctan x over 2. And for the final antiderivative, once again you note this function derivative pair. You have x squared plus 4 in the bottom, that you could be your u. Then du would be 2x dx. So I'd want a 2 and then a 1/2 out front. So this becomes 1/2 the natural, that's a square on the bottom. So this becomes 1/2 times the quantity 1 over x squared plus 4, and that should be a minus and plus c.